here we are again, and it's time to talk about AI agent memory. Now, in the previous videos, we've talked about agentic AI systems, and we've mentioned that if you want to have AI agent, you need to empower the agent with tools to take action outside the system. And if you remember, we've talked about MCP and how to configure MCP with LiveKit agent and how to connect your agent to external tools and external applications. So now your multi-agent system can think and take action. But the big question is that how to make your agent adapt your tune and your instructions without repeating yourself. And the answer is agent memory. That's the topic of today's video. First thing first, we have two types of agent memory, stateless and stateful. And unfortunately, most of us are using stateless agents. So you're asking the agent or you're sending a query to the agent and you're getting a response. And here we're talking about the first session. But when you open a new session, the agent starts from zero and you lose the previous context. So in the second session, when you send a query or you send a question to the agent, it starts from scratch without any context about the previous session. So all your instructions and all your prompt engineering tips and tricks are gone and you need to prompt the agent again. But when it comes to stateful agent, it is completely different. Now you send a query to the agent and the agent gives you a response, but it learns from your patterns and it stores your preferences and all the facts that you say in the conversation or in your query or your question or whatever. In the first session, you send a query to the agent and the agent responds back to you, but it starts storing your preferences and facts about you. So in the second session or in the new session, context preserved. So each interaction builds on previous interaction. So in the second time when you send a query to the agent, continuation from previous day, it use the memory that it is stored from the last interaction or the last session. So I remember, and then it augment. So it uses the stored facts in the memory that it is stored from the last interaction to generate the response. So that was the difference between stateless and the stateful agent. And the reason why we're trying to integrate memory to agent is that we don't want to have stateless agent, we want to have a stateful agent. So we can reuse the stored facts in evolving the agent and making the agent adapt our tune, our instruction, and in general our preferences. So it is very important for agent customization and agent personalization when it comes to fields like the medical fields or any legal firms, etc. So it has thousands of use cases. Stick with me and I'll tell you how to integrate with your AI agent. So now such an important concept to know about is memory in the loop, and I'm using this from Mem0. This is the framework that we're going to use with LiveKit in Python programming language in order to integrate our AI agent with Mem0 memory layer. And don't worry, we're going to go through all these details step by step. Just stick with me. The interaction starts with user send a query. And as you know, the agent orchestrator is the first agent to receive the query or the question or whatever the input. And then it starts thinking which tool or which agent or which memory to read or which piece of information to use. So after the orchestrator agent think about your query and it think about which agent to call or which tool to call in order to send you the response. Let's say we're going to take this path together. So let's assume that you've sent a query to book a calendar or to access information from Slack channel or whatever the thing that requires connecting your agent to external app or external tools. So the orchestrator is going to send a request to this tool inside the information sources that you have inside your agentic system. And then it's going to send the results to the collector that contains all the RAG, retrieval augmented generation, and the memory context from the previous interactions. Now, after collecting all the information and all the needed details, it's going to send the entire context to the LM in order to generate the response. And finally, it sends the response to the user. So the last step is the most important step because the purpose of agent memory is to store the interactions after the session. So as you are talking more, the agent is getting better or the agent is evolving. So today's topic is mainly about this step, which is very important step and it's going to drastically change the performance of the AI agent that you are developing. So we're going to consider this part, and we're going to add this layer in our project, which is Replexy. By the way, it is open source, available on GitHub. But anyways, let's get back into the topic. Now, one thing that you need to understand is that context window isn't memory. We are using ChatGPT, we are using LLM providers like ChatGPT from OpenAI, any kind of LLM. So when you start the session with a new ChatGPT chat, it is simply storing all the preferences and all the instructions in the context window. And the thing is that once you close the session or once you start a new chat, this context window is gonna vanish because it is designed only to store information inside the session, or in our case, if you are using ChatGPT, inside the chat conversation. But context window and memory, so both are forms of memory in a broad sense, but the key difference is that context windows are ephemeral and the session bound, which means that once you start a new session, all the stored instructions and all the stored references are gone. So while memory sticks around and builds on previous interactions, this persistence is what gives AI agent that sense of continuity and personalization. And this factor is very important, and we're gonna see why and how. So as we can see here in this comparison table, we have context window. The first comparison point is retention. Retention is temporary, and when it comes to memory, retention is persistence. Yeah, we have mechanisms in memory storing in order to delete any irrelevant values or any irrelevant instructions, but at the end of the day, the purpose of memory is to have persistent retrieval. We have the scope. In context window, it is flat and linear, but in memory it is structured, which means that it has like priorities, which information is less important or which instruction is more scaling cost. Yeah, scaling the context window is expensive. On the other side, memory or scaling memory is way cheaper, and we're gonna know why. Latency, it is slower. Memory is designed to be fast. So yeah, as we can see from this comparison table, they are different. They are serving different purposes. So now we understand what's the difference between context window and memory, and both are two different things. But I'm sure that you have another question, which is why RAG is not the same as memory. If we are using RAG or retrieval augmented generation for tasks like FQA, so I think it's kind of memory, or it is very, very similar to memory, but this is not 100% true, and we're gonna see why. So while both RAG and AI memory systems retrieve information to support an LLM, they solve very different problems. Now, when it comes to RAG bring external knowledge, any source of information. So it brings external knowledge into the prompt at the inference time. So you are talking to the LLM, or let's say you are talking to the agent. If you are using RAG, the knowledge is being used in the inference time. So while you are talking to the agent, it sends a call to fetch values from the vector database or whatever the way of representing knowledge, because we have different ways like knowledge graphs, vector databases, etc. But it's not the topic of today's video. So once you ask the question, it sends a request to fetch values from the external knowledge, and it uses these values in the inference time, which means that it sends the information to the LLM as a fact. So if I asked what was the price of this coupe, so it's gonna send a query to the knowledge base and it will return the price. And once we have the price is going to be used or it will be projected into the prompt at the inference time. And you should expect that it's going to be slower. But anyways, it is useful for grounding responses with facts from documents or any kind of knowledge representation. But RAG is fundamentally stateless, which means that the file that you has in your system isn't evolving with your instructions, or isn't evolving as you are using the AI agent system or whatever the system that you are working on. So it has no awareness of the previous interactions, like user identity or how the current query relates to past conversations. Memory, on the other hand, captures user preferences, as we mentioned on the previous slides. It captures user preferences, past queries, decisions, and failures, and make them available in the future interaction. And we can package all these amazing features in one feature, which is AI agent evolvement. So the purpose of memory is to have an AI agent that can evolve as you are using it. That's the main purpose of agent memory. You can check all these resources from the links that I'm going to leave in the description below. We have only 2 links, one from Mem0 and one from Medium article. So just feel free to check all these resources if you want to check the original sources. So now it is clear what's the difference between RAG and agent memory. Now, as we have long-term memory and short-term memory, AI agent also has the 2 types of memory. So we have short-term and long-term memory, and they are serving different purposes. So at a foundation level, memory in AI agents comes into 2 forms. The first one is the short-term memory. It holds the immediate context within a single interaction. But the long-term memory resists knowledge across session. So just like humans, these memory types serve different cognitive functions. So short-term memory helps the agent stay current in the memory, but on the other side, long-term memory helps it to learn and personalize and stores facts and values interactions for long-term usage. Now we have different frameworks that we can use for applying agent memory, but I prefer Mem0. So the first step to use Mem0 is just to go to Mem0, and here we are. By the way, it is open source project, so you can check their code and pretty much everything. So I'll start for free. They have a free trial, which is more than enough. Now this is the dashboard of Mem0, and this is my new account. So I have just few interactions. As you can see, just 16 requests. And here we have dashboard, request. And by the way, tell me if you want to have a deeper tutorial about Mem0 only, because this platform is very sophisticated and they have so many things to talk about. But anyways, let's focus on the purpose of today's video. Now, as you can see here in this tab, we have entities. So in Mem0, the source of memory is being defined as entities. So this is the playground of LiveKit. So we can just open playground, which is the LiveKit playground that we've been using for testing LiveKit AI agents. So I'm going to open this. So 6 days ago, I was talking to the agent and I said facts like I'm a technical user. My industry is customer support. I work at Sky. Just random thing to test the way of capturing the instruction or the way of capturing information to be used in the next sessions. So we're gonna try all these things together, but first make sure to install their package with this command pip install mem0 AI, so you can use their framework with LiveKit SDK. And all you need is just to pull your credentials, and then the next thing is to copy your credentials to be used in the project. So once you open the API key from your account, you're gonna paste the API key here in this variable in dot. So as we can see here in agents.py file, that all the AI agents that we have in our multi-agent system that we've built in the last videos. So the starter agent receives Mem0 user ID from job metadata or the room name. So it can store it in session context. And as we know, now all the agents are inherited from Orchestrator agent. So they all use the same session context. And this is something really important or under the same Orchestrator agent. So here in Orchestrator class, as we can see, we have this method right here, which is in the conversation, because as we've mentioned, we start storing all the instructions at the end of the session. Let's try to say something to the agent. So I'm going to use this command uv run python source / agents py. Oh, I forgot to add console, so we can test it from our console.
I'm your assistant. How may I assist you today?
Hey, I want to tell you something about me. Now, first of all, I go to the gym like 3 times a week, and as a matter of fact, I'm living in Manchester City, and yeah. What do you think?
It's great that you have a regular gym routine and that you're living in a vibrant city like Manchester. Staying active is excellent for your well-being. How can I assist you further today? I know you are working on a GitHub project related to genetic AI, which you believe will be the best project. Would you like to share more details or discuss any specific aspect of this new project?
So you're able to store facts and you're able to track my information.
Yes, I am able to track your preferences and relevant facts you share with me. This helps me support you better in scheduling consultant engagements and executive tasks. Your permission?
I'll close this session and we can go to Mem0 account. So I'm going to go back to Mem0. Here we are. So I want to check all the facts that I said in the last session. I want to check whether or not it is being stored in this entity. So we were using a console for testing. So now we're going to check console entity. Okay, so here we are. We have two new entities in console. So we have two created memory contents. The first one is user love going to the gym and goes there 3 times a week. User is currently living in Manchester City. So, and those 3 interactions were 3 days ago. So the thing is that these contents are consistent and persistent, which means that every time I open a session and every time I talk to the AI agent, it will pull and it will use all these facts. And as we can see, it categorizes the memory contents inside different categories. As we can see, personal details, health, technology, professional details. Mem0 is absolutely great choice if you want to have an AI agent that can evolve. If you want a deeper dive inside this framework, just let me know in the comments. And I'm going to leave the link of the repository. Thanks for watching and see you in the next one.